Welcome to Math Made Easy with PDY.
Um, Sir,
Yes, please.
please, I can't see the screen.
Who else cannot see my screen, please?
Okay, I can see it now.
All right. So once again, you are welcome to Math Made Easy with PDY. And for today's lesson, we're actually going to look at the topic trigonometry. This topic is so broad, really broad. And to testify that these are the subtopics you need to know under trigonometry. I believe you can see all.
Yes, please.
Good. So broad, as I said, very, very broad. Fortunately for you, it's found in both core math and elective math. And I'm not sure you've done it in core math yet. Have you?
No.
All right. So since you've not done it in core math, then it means I need to consider the topic from the core math section. Then I'll launch into the elective math section. So I'll be combining both actually. Are we all okay with that?
Yes.
Please.
All right. Good. So when we talk about trigonometry, what are some of the subtopics you'll be looking at? We'll be looking at radian measure, relationship between radians and degrees, changing from degrees to radians, and it goes on and on and on and on. As many as it's not everything that we'll be looking at. Some of them are not so much necessary. So we'll be looking at trig ratios of 30 degrees, 60 degrees, 45 degrees, and 90 degrees. Then you look at trigonometric ratios of any angle at all, and so on and so forth. But for better understanding, I'm not going to follow the pattern as shown here. I'm going to teach you in such a way that you can easily understand it so that it links up with the subtopics as is shown from this page. Good. So to begin with, someone may ask, what exactly is trigonometry? So what is trigonometry? Now, trigonometry is simply a Latin word which means triangle measurement or triangle measure. So it means that it's the study of triangles. That's the general idea of trigonometry. It's just simply the study of triangles and the measurements found on triangles. That's the whole idea of trigonometry. So it's a branch of science or mathematics that deals with the study of triangle and then the measurements on triangles. That's all. So if I may ask you, if I have a given triangle for which I know you know what a triangle is, can someone give me a definition of a triangle in her own small way? What do you think a triangle is? Yes? Oh, my people, I need your response. What do you think is a triangle? How would you define it in your own small way?
A triangle
Sir.
is a shape with
I'm listening, please. Who is talking for now?
Abigail.
Yes, so what are you saying a triangle is?
A triangle is a shape with three vertices and three edges.
Can you take it again? It wasn't clear to me.
Shape with three vertices and three edges.
Oh, okay, that's good. Any other? definition to
Triangle is a plain figure
yes.
with 3 sides.
Perfect. So all the answers you are giving, it's a good definition for a triangle. Just a two-dimensional figure or a plane figure bounded by 3 sides. And as Abigail said, has 3 vertices automatically. And therefore, someone will also say that it has 3 interior angles. Therefore, that is what a triangle is. So if I may ask, what are the forms of measurement we can make or we can have on a triangle? So measurements on triangles. Yes, what are the kind of measurements we can generate from a given triangle? It includes what? Pardon?
You can measure the height of a car.
What can we measure on a triangle, if I may ask? That's the question.
You can measure the height of a triangle.
You can measure the height. What else?
Of a triangle.
Its interior angles.
Exactly. You can measure the interior angles. Yes, what else? So in terms of saying the height, I would rather say that we can measure the sides. So we can measure the sides of a given triangle because as at now, the height has not been shown. So you can measure the sides of a given triangle. So we can have A here, B there, and C there. So we can measure the sides. Then again, here can be A, that can be C, that can be B. You can measure the sides. Then again, you said the interior angle. So you can measure the interior angles here. So we have, let's say, capital B, capital C, and capital A. Likewise, over here, we can have, let's say, capital C, capital A, and then capital B. So on a given triangle, we can measure the sides, we can measure the interior angles. And going further, then you can bring in the height when it is introduced in the given triangle. Remember, we are looking at trigonometry, and we said trigonometry is a branch of science or mathematics that deals with the study of triangles and measurements found on triangles. That's the whole idea of trigonometry. So therefore, to begin with, it is not always that measurement you have to use, let's say, the ruler or the protractor to measure the sides and then the interior angles correspondingly. Or yes, because the ruler can be used to measure the sides, or the tape measure can be used to measure the sides, or the surveyor's tape can be used to measure the sides when it is drawn. The interior angles, strictly, we have to use um, the protractor to measure the interior angles. That is one particular instrument you can use to measure the angles when the triangle has been drawn. But in this case, per our concept here, we are going to look at the calculation aspect, how you can generate the sides, how you can generate the interior angles when some of them are known and others are not known. Then you have to find those ones. So to begin with, I believe you have an idea about it. So let me just go straight to the point. Talking about the measurement of the sides, it was first established by a gentleman known as Pythagoras. And this gentleman or mathematician or scientist, Pythagoras, just limited himself to the study of right angle triangles. So Pythagoras started studying right angled triangles. And we know what a right angle triangle is. Yes, can someone give me a simple definition for a right angle triangle? Yes?
A right angle triangle is a triangle that has one of its interior angle as 90 degrees.
Thank you. That is so perfect. So a right angle triangle is simply a triangle having one of the interior angles exactly as 90 degrees. So I'm just drawing my right angle triangle for you to have a look at it. I just want to use a different color for that. So I have my right angle triangle drawn here, for which in this right angle triangle, the 90 degrees has been shown. And then the sides of the right angle triangle is A, B, and C. So Pythagoras came up with a theorem which said that the sum of the squares of the two legs is equal to the hypotenuse. Automatically, the hypotenuse is the longest side of a given right angle triangle, and it is always a side for which the 90 degrees faces. That's the whole idea of hypotenuse. So let's say our C is the hypotenuse. Our C is the hypotenuse. And the other two sides of the right angle triangle are known as the legs. Therefore, Pythagoras said that the sum of the squares of the two legs should be equal to the square of the hypotenuse. So he said a squared plus b squared should be equal to c squared, and not a plus b is equal to c. No, it doesn't mean a plus b is equal to c. No, but the sum of the squares of the two legs should give you the hypotenuse square. So this is the establishment Pythagoras made on trigonometry when he was actually investigating the concept of triangles and the relationship that lies between the sides of a given triangle. And maybe I'll find another day to explain how this formula was established. Unless maybe you want to know it right now, and I can go ahead and explain how this formula was established. Do you want to know it right now?
Yeah, you can go ahead.
I can go ahead.
Yes,
Thank
please.
you. All right. So going ahead, this is how Pythagoras established this rule. Now, he took the triangle. So I'm drawing it again. The right angle triangle. And as I said, labeled the sides as A and B, and then the hypotenuse as C. And then in this case, what he did was he copied whatever he had here, because he was relating this thing to a square. So he copied 4 of this structure, 4 of this triangle he has drawn. So let me copy the triangle drawn here. I need 4 of it. Let me see if I can bring them out one after the other. Okay, so this is one. All right. So then he placed these 4 triangles side by side in such a way that it forms a square. So look at what I'm going to do carefully. Sorry. Undo. Okay. So, my dear student, I believe as you can see, the four triangles have been placed together. And what structure does it forms now?
A square.
A square. Yes, I'm trying my best to make you understand. That's why I'm using this diagram to get things going. Therefore, as it has formed a square, help me with the sides of that square. What's the name given to this side of the square? This side of
The
the square
length.
is what? What would
The
be the
length.
that is the length, but what would be the full dimension of the square? Previously, it was A and B separately, but right now, what's the full length of the square? This side will be labeled A plus B. Here is also A, sorry. So this full side is A plus B. Do you agree? And it's the same thing
Yes.
here. So here is also A plus B. How about this side? Here is A. Here is also A. So how about this side? Here is also A plus B. And the opposite side is still going to be A plus B. Do you agree with that?
Yes.
Okay. So here it is. Look at how many squares do you see in the whole diagram?
2.
We have two. So one square is simply formed as a result of having, let's me go faster. As a result of having A plus B here, A plus B, it goes along. So it's the same thing, A plus B here, A plus B there. And then we also have another square. This time around, what's the dimension for that square? There's a smaller square. And what's the dimension?
B
For
multiplying.
that is C. You have C here, you have C there, you have C there, you have C there. Do you agree that that's the inner square you can see there? It's not B multiplying C. Actually, when I rotated it, one of the figures rotated, but this shouldn't have been there. The B shouldn't have been there. So let me just see how I can erase the B alone. No, it's too big. The B shouldn't be there. It should be left with only the C in there. All right. So it means there's a connection between A plus B and then C. That's all. That's the connection we want to look at over here. So if we want to find the area, we actually use four triangles. It has given us a square altogether. So what's something here? It means area of this first square. Let me call it square 1 and square 2. That is going to give us something like A plus B multiplying A plus B, right? And that is going to
Yes.
be A squared plus 2AB plus B squared. Does it make sense?
Yes.
Okay. Then we go to triangle, area of the second one, which is found here, So that is going to give us area of square 2, which is C squared. I hope it makes sense. But how
Yes.
do we connect this? Let's consider area of a triangle. How do you find the area of a triangle? Area of a triangle is given as what?
Yeah.
Half base times
And
perpendicular height, right?
yes.
Good. So if I consider of the triangles, for which one of the triangles, I want to see if I can get Control V. Good. Oh, undo. Hold on. Let me just go back.
Okay.
If I consider one of the triangles for which I had it as this, just go as that. We had our A was here, B was there, and then our C was there. Now, finding the area of this triangle, it is going to be simply A is equal to half of the base. The base can either be A or B. So we have half of the base times perpendicular height, which can also be the A or the B. So we have half of AB. But how many of the triangles do we have given as the square, if I may ask? How many of the triangles came together?
4.
4 of them. So if 4 of them gave us the square, then it means area of 4 of the triangles will be equal to 4 times half of the AB, or half of the A plus B. And that is going to give us what expression? That's going to give us 2AB, right? That's giving us 2AB, right? Because 2 will cancel out that, and that will be left with 2AB. Are you with me?
Yeah.
Yes.
So now watch something here. Watch something here. We've seen that area of this first triangle is A plus 2AB plus B squared, right? And then area of
Yeah.
the square here is that. So if I may ask you, if a given structure is like this, and then now you want to find, let's say, the shaded area here, you want to find this. How can you generate the shaded area here? If you have been given a triangle, 4 triangles, or a square like this, and then what you don't know is the inner square which is found here. How do you connect them? How can you find the area of the shaded region which is inside here? It is simply finding the area of the bigger square and then doing what? Subtracting the area of the 4 triangles, isn't it? That's how you can find the area of the inner square. Doesn't make sense?
Yeah.
So we can say that area of smaller square is equal to area of bigger square minus area of 4 triangles. So what establishment have we had for the area of the smaller square? We've seen that area of the smaller square is given as what? C squared. I hope it makes sense.
Yeah.
Then area of the bigger square has been established as what?
A squared plus 2ab
A
plus
squared
b
plus
squared.
2ab plus b squared minus area of the 4 triangles. What have we established it to be?
2ab.
2ab. So when we simplify the right hand side of this equation, we'll have c squared equal to what is left?
A squared plus b
A
squared.
squared plus b squared. And this is quite easily done. And this is how Pythagoras established the rule that if you want to find the relationship of a right angle triangle, it is given as the sum of the squares of the 2 legs should be equal to the square of the hypotenuse. Please, does it make sense?
Yes. Yes, please.
So this is how it is. And this is being used in our everyday life activity. So this is how the establishment was made. Remember, we said trigonometry is the measurement of the sides and angles of a given triangle. We have different types of triangles. We have right angle triangles, we have obtuse triangle, we have acute triangle, we have scalene triangles, we have isosceles triangle, and then we have equilateral triangle. But when it comes to the relationship between the sides and then the interior angles, they don't go the same way. That is why the investigation on trigonometry started with right angle triangles. And the first establishment made on right angle triangles was the sides of a given right angle triangle. It will interest you to know that any type of the triangles that you can generate them from a right angle triangle. If you draw an equilateral triangle right now, let's take it that this is my equilateral triangle. All the sides are equal. I can form a right angle triangle there by simply introducing a perpendicular height. If I have, so let's take it that this an equilateral triangle. All the sides are equal. Now, how many right angle triangles do I have in there?
2.
Now, if I also have a scalene triangle, which is like this, meaning all the sides are not equal. Do you agree? I can form a right angle triangle by simply introducing a perpendicular height.
Yeah.
So that is why the idea of trigonometry started from right angle triangle. If I have the next one, which is let's say
I,
isosceles triangle, right?
yeah.
Yeah, so isosceles triangle, I'm trying to draw an isosceles triangle, whereby we know two sides are equal, right? Let me clean
Yeah.
this thing from here. I can form right angle triangles by just simply introducing a perpendicular height. It can just be here or it can move from here to the other side, any of them. So that is why the investigation on triangles began with right angle triangles. That's all. So now we've seen that whenever we are given any triangle, specifically right angle triangle, for which the sides are known, some sides are known, let's say two of the sides are known. To get the third side, you can actually use the idea of Pythagoras Theorem to establish it. So let's take one example. If this is my right angle triangle, and then I have my hypotenuse known as 5, and then one of the legs as 4, and I'm asked to find x. Straight ahead, it means I need to think about what idea.
What?
What idea is
Pythagoras.
Pythagoras theorem. So I can just go straight ahead and say that c squared is equal to a squared plus b squared. And therefore, my a and b can be alternated using the 4 and then the x. So my 5 is automatically the c. So I have 5 squared is equal to x squared plus 4 squared. So finding x, it will be 25 minus 16 equal to x squared. So x is equal to square root of 9 and x is equal to what? 3. Are we okay?
Yeah.
Please don't forget this. The relationship began with right angle triangles. And therefore, the first establishment came from Pythagoras. And he came with the Pythagoras theorem. And the theorem, once again, is c squared is equal to a squared plus b squared. It tells you the relationship of the sides of a given triangle, right angle triangle. Can I move on?
Yeah.
Then again, another establishment came on board. And this time around, the establishment was not about the sides of a right angle triangle. This time around, it was about the relationship of the sides and their corresponding interior angles. So having the right angle triangle, but this time around, looking at relationship between the sides of the right angle triangle and the interior angles of the right angle triangle. And this investigation brought about what we call the trig ratios, trigonometric ratios. So the trigonometric ratios that we are going to actually talk about right now tells you about the relationship of the sides of a given right angle triangle and their corresponding interior angles. Are you with me?
Yes.
So if I have a right angle triangle drawn and I know that the relationship of the sides are A, B, and C, but the corresponding interior angles are going to be, let's say we have, let me call this one theta, and then the other side as alpha. From investigation, it's realized that there's a connection between the interior angles and then two of the sides. So if I limit myself to theta, there's a connection between A and B and theta using a particular trig ratio. Likewise, there's a connection between C and B and theta. Likewise, there's a connection between A and C and theta. Are you following what I'm saying? There's a relationship,
Yes.
and that relationship is given as a ratio. That relationship is given as what? A ratio. Maybe not to bore you so much, I wouldn't like to go detail into the investigation, but this is how those investigations were established. This is how the investigations were established. The basic trig ratios are 3, but for elective math purposes, we go beyond the basic trig ratios, which are 3, and they become 6 for elective math. But for core math, you are limited to 3. So the trig ratios are basically the sine ratio, the cosine ratio, the tangent ratio. So these are the basic trig ratios, basic ones. And then we have the other ones, which are cotangent, cosecant, and then we have the secant. So these are the other trig ratios, but the basic trig ratios are 3. Therefore, what is the definition of the basic trig ratios? Now, let me give you the sign, the symbols for the ratios. The symbol for sine is actually given as sin, but it's sine. The symbol for cosine is cos. The symbol for tangent is tan. The symbol for cotangent is cot. The symbol for cosecant either is written as CSC or COSEC, cosecant. Either you write it CSC or COSEC. And then the symbol for secant is sec. Student, are you with me?
Sir, please,
Yes,
I can't see it.
You can't see what?
The writings are not clear.
Oh, are you sure? Sine ratio, cosine ratio, tangent, cotangent, cosecant, and then secant. And I'm saying these are the symbols: sine, cos, tan, cot, cosecant, and then sec. Are you okay now?
Yes.
Okay. So when we say ratio, how do you understand the concept of ratio? I know maybe you've not done it in SHS for now, but in JHS you did it. What is ratio? Yes, that's a ratio. Any idea about what a ratio is? I'm listening, my dear students. We have Abigail, Francina, Emanuela, Paulina.
I want to try.
Okay, thank you. I'll be glad for you to try it.
So something that can be written in a fraction.
Okay, so you are saying it's an expression that can be written in a fraction form. I believe you cannot see my screen. I moved away from the screen, but can you see it
Yes,
now?
please.
All right. So comparing two quantities with the same unit, that's what ratio is all about. Comparing two quantities with the same unit. So I can compare two quantities either by writing it in a fraction form or not. But we use the symbol is to, the colon symbol, to represent it. And therefore, writing the ratio of A is to B, it means I'm comparing A and B. And we can change it from the state here to a fraction state and it becomes A over B. Are we okay? Did I hear no?
Yes, okay.
Okay, why are you lost? Let me help you. I said ratio is simply comparing two quantities. And in other words, if I have ratio of boys to girls, let's say ratio of 9 boys to 3 girls, what will it be? It's going to be 9:3. And 9:3, we can reduce it to become 3:1. It means when you pick 3 boys, it is equivalent to 1 girl. That's what it means. And how did we get the 3:1? By using simple division. So we had it as 9/3. 3 can go into itself 1 and go into 9 3 times. So it becomes 3/1, which is the same as 3:1. That's why we said that comparing two quantities of the same unit is all about the idea of ratio. Are you okay now?
Yes.
Any question before I move on? Because I'm going to talk about the basic ratios right now and what their ratios are going to be. That's what I'm going to talk about. So for what I've said so far, if you have any problem, let me know before I move on. So can we continue since there's no question coming?
Yes, please.
All right, good. So talking about the ratios, if I may ask, what are some of the ratios can we generate from here in terms of the sides? Yes, help me with the ratios. What are some of the ratios we can generate from the sides of a given triangle, which is what I have here? We can have a ratio of what? A is to C, which is the same as A over C. Does it make sense?
Yes.
Yes, which other ratio can we generate? A is to B, which is the same as A over B. We can, and I also heard B is to C, which is the same as B over C. Yes, which other ratio again can we have?
B is to A.
So B is to A, which is the same as B over A. And then
C is to A.
C is to A, which is the same as C over A. And then B, oh, C
C
is
is
to
to
B.
B.
All right, which is the same as C over B. It will interest you to know that whatever we are having here, please watch carefully. Whatever we are having, B over A, which is found here, is a reciprocal of this, A over B. And likewise, C over A is a reciprocal of A over C. When I mean the reciprocal, this is what I mean. It's like having, please watch this carefully, because I'm establishing it before I come and quote them here. If I have B over A, when I reciprocate it, then it becomes A over B. But how did I reciprocate it? So it's like finding the inverse of it. So 1 over that expression. How did I get it? Watch. If I find 1 over B over A, for which is going to be 1 divided by B over A, going further, it becomes 1 times A over B. So that is going to give us A over B. I hope it makes sense. So the in the same way, if I have 1 over C over A, when you go further, which is the same as 1 divided by C over A, that is going to be 1 times A over C, and that is going to give us A over C. So it's like the inverses or the reciprocal of this expression gives you what is down here. That is why, interestingly, these 6 ratios that you've given to me here from the right angle triangle gave birth to the trigonometric ratios. How many trigonometric ratios have I written?
6.
There are 6, and it is compared with the trig ratios as you have here, or the ratios that you've given to me from this right angle triangle, from the right angle triangle here. So let's box on. How did this expression establish? Watch it carefully, please. So let's take it that I don't want to quote it for you, even though some of you may know it. Yes, but I want you to know it very deeply, because if you don't get this concept right and I launch into the deep, you will find yourself in trouble. So please follow this carefully, I beg of you. Let's take it that I'm going to change my screen into a graph. So this is my grid lines for the graph. And for that matter, let's take it that I have my I have my y-axis here, and I equally have my x-axis here. Let us draw a given triangle, or let's put some dimensions there. Let me just use small of that. So I have, let's say, 1, 2, 3, 4, 5, 6, 7, and then 8. Now, I'm going to start with, okay, then the y-axis. So this is my x-axis, that's my y-axis. On the y-axis, I have same dimensions. Maybe I'll take the measurements later on. So we have 1, 2, 3, 4, 5, 6, maybe 7 up here. I'm going to draw my first right angle triangle on this. So drawing my first right angle triangle, I'm using a different color. I'm using green. I draw a right angle triangle for which the dimension begins from 0 and ends at 2. And then I introduce a vertical height which ends at 1. And then I introduce a diagonal to meet here. Okay, so from our right angle triangle drawn here, please help me with the dimensions. What dimension do we have down here? From, let's say, let me call O here and A here. What's the dimension, please? What dimension can we give to it?
2 centimeters.
2 centimeters. So let's take that it is 2 centimeters. And then the dimension from this end to that end is what?
1 centimeter.
1 centimeter. Very good. So what don't we know on this right angle triangle?
The hypotenuse.
The hypotenuse.
We don't know the hypotenuse. Likewise, we don't know what else? The some of the interior angles, right? We don't know this interior angle. Likewise, we don't know here. Do you agree?
Yes.
Good. Now, going further, maybe let us measure it so that it will be more clearer. Maybe getting the measurement will be more perfect. Shapes, no, applications. Then I go to, I need ruler. Where is the ruler? Okay, ruler is here. Okay, let me see. Using the ruler, please, what dimension are we having? I believe it's 4, right? You see it as 4.
4 centimeters.
Yes. So
Yes.
4. Good. And then let us turn it and then measure the other side. Let's turn it and measure the other side. Okay, let's measure the hypotenuse automatically. What are we having at the hypotenuse if you try to read? What value is that? Let's say around 4.5. Is it true?
Yes, 4.5.
Then let's take the measurement for the other side. Maybe that would be better. Yeah. That is 2. Does it make sense?
Yes.
Okay, so we have, watch here, please watch. I'll just use 2 of the triangles to establish the rules, so you'll be fine. We have O, A, we have B here. So OB, which is actually the hypotenuse, is giving us a dimension of 4.5 centimeters. Then we have OA, giving us a dimension of 4 centimeters. I hope it makes sense. And then we have AB, giving us a dimension of how many was it?
2
centimeters.
centimeters.
Okay, let's see whether they link up slightly. Let's see whether they link up. So linking up, please take your calculator to investigate. It means our OB squared should be equal to OA squared plus AB squared. I hope it makes sense. Like, that's the establishment we've had from Pythagoras Theorem. So let's find out. Is it true that if I find OA, which is 4 squared plus AB, which is 2 squared, and I find the square root of that answer, I'm just taking that so that I can see what I'm writing, and I find the square root of that answer, will it be equivalent to 4.5? Please check it for me from your calculator. Try it.
It's 4.47, which is equivalent to 4.5.
Oh, so you had 4.47, which is almost approximately, okay, equivalent to what? 4.5, right?
Okay.
So it means that, student, are you with me?
Yes.
Whatever we drew here is not just a drawing, no. It has some connections, and that connection actually is coming from Pythagoras Theorem. Now let's take another one. I'm just going to increase the triangle a little So I'm going to increase the triangle. So increasing the triangle, I'm going to move from A to another part, which is, let's say, at 5. I'm going to move to 5. So this time around, let me use a blue color. So I'm expanding from line. I'm expanding from O all the way to where the 5 is. And then I will expand the hypotenuse as well. So it means falling on, I'm just enlarging the smaller triangle. So I've enlarged it just slightly, yes. And then I have my vertical height here. So from whatever I'm having here, here is going to be B1, here is going to be A1. Do you agree that it's just an enlargement of triangle OAB that has given me triangle OB1A1? Do you see it as that, please?
Yeah.
I've just enlarged it, increased the size. So in this case, let's go again with the measurement. So let's take the measurements. Where's my ruler? Okay, my ruler is here. I've just drawn it, but let's measure. Yes, OB1 is almost what? It's like,
11.
is it 11?
11.
11.1, isn't it? It's like 11.1. Do you agree?
Yes.
Okay,
please.
Yes, please.
so note it down. I just want to rotate so that we measure the other one as well. And then OA1 is going to be what?
10.
Yes, it's 10.
10.
It's 10. Good.
Then,
Then finally, we will be establishing the rule very soon. Don't worry, you'll be fine. Because when you get the basis right, trust me. And this one is what? 5, right?
yes, please.
Good. So we have, help me with the values that we've calculated for. They are OB1 and then OA1 and then AB
A1, B1.
A1B1. Thank you. I'm happy you are following. OB1, we had it as 11.1 centimeters. OA1 was 10, right? Was it 10?
Yes.
And then AB1 was what?
11
5.
point.
Are we okay? So
Yes.
let's
Yeah.
investigate whether it is true. Let's find out whether it is true that the values that I've written over there, they are true. They relate from this right angle triangle. So in doing so, it means OB1 all squared should be equal to OA1 all squared plus A1B1 all squared. Let's put the values there. OA1 all squared was 10 centimeters. So 10 centimeters all squared plus 5 centimeters all squared. Then we find square root of it. Please use your calculator to help me with the investigation. What are we getting?
11.18.
Oh, 11.18 centimeters. And it is approximately, let's say 11.2, right? Which is very close to OB1, right? Which is very close to OB1. Do you agree? Do you agree, please?
Yes.
Okay, now this is what we are going to do finally. Finally, we are going to measure the angle here. We are going to measure the angle here, meaning BOA. We are measuring angle BOA. Do you know that angle BOA and angle B10A1, they are the same? Do you agree? Do you agree that angle BOA Remember we had two triangles. I need your response. Remember I've told you I need your response a lot.
Yes, please.
So we have one triangle which is O, B, and then A. And we have another triangle which is bigger. And that one is actually O, A1, and B1. And I'm saying that I believe you know that the angle O is common to these two triangles. So if here is theta, here is also automatically theta. Do you agree?
Yes.
Okay. Do you agree, please?
Yes,
Yeah.
please.
All right. Now watch.
Yes.
This is where the ratio is coming in. Please, I beg. So watch. So we had OA as 4. We had OA1 as 10. We had what's the name? OB as 4.5. Sorry, 4.5. And we had AB as 2. We had AB as 2. Likewise, when it comes to A1, B1, we had it as 5. And then here was 11.1. These are values we've established from our readings we had here. The only thing we did not know was the angle. Let us measure the angle, which is angle theta, which I've placed here. And I said it is common to all of them. So let me go for my protractor and let's take the measurement. So this is my protractor. Today we are using practical means of getting the answer. Tomorrow is all about calculation. So please be careful and understand it well. So I've positioned my protractor. The center of the protractor is there, and then my zero arm is here. I'm taking the measurement. Please, I've taken the measurement. What angle are we getting there, please? The reading is there. Can you see the reading?
No.
There's a reading. The reading is here. Watch. Here. It's what? 26.5. Okay, maybe let me move it away so that you see it clearly. Yes, what's the reading now? It's like 26.5 degrees, right?
So 26.5.
Good. So we've seen that angle theta from both diagrams is 26.5 degrees. Take your calculator. Please take your calculator. Are you all ready with your calculator? Are you ready with your calculator? Because you are going to do some operations for me.
Yes, sir.
All right. So if the angle is 26.5, one ratio is 2/4.5. Another ratio that we have here is 4/4.5. Now, its equivalent ratio we have on the second diagram is 5/11.1, and the other is 10/11.1. Okay, so kindly program 2/4.5 on your calculator and tell me the answer. 2 divided by 4.5. What is the answer?
So 0.444.
0.444. Now, clear the screen and then program 5/11.1. 11.1. 11.1.
0.45.
So that is 0.45. which is almost okay, you know, it's drawing, so it is almost closer to 0.444, right? Okay, so let's go back to the first one. So it means these two informations relate, they connect. Let's take the next one. 4 divided by 4.5. What are we getting?
0.8.
Okay, and then 10 divided by 11.1.
0.9.
Okay, so it's also slightly connected to that. They relate. If you approximate it to one decimal place, you realize that they relate. Now, let's come back to this one. And then let's investigate which trig ratio goes along with it. We had 2 divided by 4.5. And the answer it gave us was 0.4444. How do we get that answer very close to the angle here? Now, find sine of 0.444. Sorry, sine inverse. Sine inverse on your calculator. I hope you've seen sine inverse. You press the shift button
Yes,
and
sir.
yeah, so sine inverse of 0.44444. Please, what answer is it giving us?
So 26.39 approximately.
Approximately. Do you see that it has having a connection with the theta value here?
Yes.
Okay, then let's go for the 5 over 11.1. 5 divided by 11.1. What was the answer?
0.6.
Okay, so find sine inverse of the answer. Do you see it very close to 26 point that? Hello? Are you here?
85 what?
I can't hear what you are saying.
So 26.74.
Okay, so what it means is that when we found, watch, sine theta was equal to 2 over 4.5, and then finding theta, it was sine inverse of 2 over 4.5. We had theta value as 26 points. You mentioned something. 26 point what?
74.
74. Okay, let's say 26.74. Then again, we equally took sine of theta is equal to 5 over 11.5 or 11.1, sorry. Theta became sine inverse of 11.5 over 11.1. And that theta value was also equivalent to 26.7, right? Right? Am I right?
Sir, please, the first one.
It's what?
The first one, the sine inverse of 2 over 4.5.
What was the answer?
6.38.
Oh, 26.38. Don't worry. Don't worry about the value at all. We are interested in just the main angle, so don't worry about it. So in this case, per whatever we've established here, now watch this carefully. Have you seen the position of the theta value? Have you seen the position of the theta value in both triangles, please?
Yes, please.
Now, if you look at it carefully, you realize that the value opposite to it is what number?
Yes.
The value opposite to it is what number, please?
2.
And the 4.5 is representing what from the right angle triangle?
The hypotenuse.
Okay, then again, the value of theta in the second diagram, the value opposite to it is what number?
5.
And then when you consider the right angle triangle, the value of the 11.1 is representing what of the right angle triangle?
Hypotenuse.
So in other words, we've seen that there is a relationship. If sine of the angle is not known, the relationship here is what? The opposite value to the angle divided by the hypotenuse of the triangle. That's the establishment that has been raised. That's the establishment we've had right now. So this is the first trig ratio we've established, which is sine ratio. The sine ratio is the opposite side over the hypotenuse should give you sine of the interior angle. And please, this establishment is based on where the angle is positioned. Please be careful. Sine of the angle position is equal to the opposite value to the angle divided by the hypotenuse of the triangle. That's the first establishment. Please, can I move on so that we can investigate the second one as well? Can I move on?
Yes.
Now, so the second ratio we want to investigate is the cosine ratio. Cosine ratio. That's the second ratio we want to investigate. So investigating the cosine ratio, now, this time around, we've already used the 2 and then the 4.5, the 5 and then the 11.5. This time around, let's use the 10 and 11.5 and then the 4 and the 4.5. Let's see whether they have a connection. Let's see whether they have a connection. Let me copy that to a different page and then let's see whether they have a connection. So take your calculator and help me with the programming. Program 4 divided by 4.5. What answer are you getting?
0.889.
So when you divided 4.5 by hold on. When you divided 4 by 4.5, you had 0.81.
9. No, it's 0.888.
Okay, so 89. Now, how about the 10 divided by 11.1? What is the answer as well?
0.9.
Okay, so it is approximately okay, 0.9. 0.9. Now, this is approximately 0.9 as well. Do you agree?
Yes.
So they connect as well. All because this triangle here is similar to that. And for the fact that you've enlarged this triangle to become this, you've increased the size of this triangle to give you what is here. Good. Now, so we have sine, this time we are talking about cosine. So let's find cos of the angle theta. We don't know the angle. Let's say that we don't know the angle. It's equal to 4 over 4.5. Therefore, to get theta, theta is equal to cos inverse of 4 over 4.5. Can you use your calculator to help me with the investigation here? What are you getting?
27.3.
20.
7.3.
Oh, are you sure? Cos inverse
It's 27.
of
Yes.
4 on 4.5. Hold on, I'm coming. 4 on. Okay, then do that of the other operation for me. Let's see the answer. Oh, sorry. So you had 27 points. I'll come back there. So cos theta is equal to 10 on 11.1. Theta will be equal to cos inverse of 10 on 11.1. Please work this one out also for me.
25.7.
25.72.
0.72.
And you said this one was 27.
27. There was there were some decimals.
27 point what?
Say a minute.
All right.
27.26.
Okay, so approximately theta here is given as 27. Approximately theta here is given as 26, which actually is not supposed to be so. Maybe
Sir.
there's, pardon?
I think theta approximately.
Yes.
That's I will give 27, not 26, because it's 25 point. Sorry, 26.72.
Oh, okay. From the sign, it was 26.5, so which is approximately 27, which is 27. Okay, so ideally theta value must be 27. So this is the relationship that we've established here. So it means that when it comes to the trig ratio, which is known as cos of the interior angle theta, depending on wherever the angle theta is positioned, it should be equal to the adjacent side. You know where theta is positioned here, the 10 is on the side of the theta. So we say that is the adjacent side. Adjacent side divided by the hypotenuse. Are you following me? So the ratio between the adjacent side and the hypotenuse should give us cos of the angle theta. That's the establishment here. So this is the next ratio known as the cos ratio or the cosine ratio. The cosine ratio. So the first ratio is sine ratio, which is given as the opposite side over the hypotenuse. And the next ratio is adjacent side over what? Hypotenuse. Remember, we have investigated these numbers and we are using it to establish the ratio, the cosine ratio, and then the sine ratio. So it tells you that whenever you have any given right angle triangle and some sides and some interior angles are known, you should be able to know how to establish the other sides which are not known. So let's take it that we have probably 4 here and then we have 8 here, and I'm asked to find the angle theta. Hold on. Let's say 8 is rather here and 4 is here. We have 8 here and 4 there because the hypotenuse is always longer, right? So I have 8 as the hypotenuse, 4 as my side here. It's one of the legs. Per the position of the 4 and the angle I'm looking for, what's the relationship between them? They are what to each other? Are they adjacent or opposite? Which one? The 4 and the theta. I said the 4 and then the theta. What's the relationship between them? Are they opposite or adjacent? They are opposite to each other. So in other words, if I want to find theta, which is the angle in the triangle, and I know my opposite side, and the 8 is automatically representing what side? The 8 is representing what side?
The
Hypotenuse.
hypotenuse.
Then in this case, which trig ratio should I have in mind to help me find the missing angle?
Sine ratio.
The sine ratio. So it means you just write it as sine of the angle theta should be equal to the opposite side of the angle, which is 4, divided by the hypotenuse, which is 8. And hence, finding theta, it is sine inverse in finding theta, it is sine inverse of 4 on 8. And please, what's the answer going to be? Theta will be what value? What will be theta value? It will be what? 30 degrees. 30 degrees. 30 degrees. So what if I place x here and I'm asked to find x still from this diagram? How can I generate the value of x?
Where is the x?
I've placed x here. How can I generate the value of x?
It's going to be x squared will be equal to
X squared will be equal to 8 squared plus 4 squared also.
Are you sure?
it's going to be 8 squared minus is it 4 squared.
Yes, it's supposed to be x squared is equal to 8 squared minus 4 squared. That then it means you are using Pythagoras theorem to find the missing side. All right, our time is actually up, so I want you to try this question for me, just this question, and then when we meet the next time, we'll continue from there. So find the values of the missing letters. Find the values of the missing letters in the diagram. So I have my diagrams drawn. You just have to take a screenshot of it. Okay, so just take a screenshot of this and work it out for me. When we meet the next time, we are going to take it from there. Find the values of the missing letters in the diagram. So over here, you are finding theta. Over here, you are finding theta. Over here, you are finding both theta, alpha, as well as the value of x. And this is the only information given in the diagram. Thank you so much for joining the call. As I said, I have a YouTube channel. Kindly visit the channel. The name is Math Made Easy with PDY. Subscribe to the channel and give me your support. Thank you so much and have a lovely day. See you next week. Bye-bye.
Bye.